Time for Module 6. We're looking at inverse functions in this section. So we have a question. What is an inverse process? Well, an inverse process simply undoes what some original process did. So we're familiar with this. We do a forward progress, and then sometimes we need to undo it, so we do the inverse process. So maybe we need to dig a hole, and the inverse process to that would be to fill the hole. So maybe we're planting a tree, dig the hole, put the tree in it, fill it back up with soil so that the ground is revised. If golf, you hit a divot, you're supposed to replace it, put the soil back in, again, leave the place as you found it. So undo any damage you did. What about filling a pool with water? Well, occasionally we need to drain a pool. So we've got it full, and some reason we need to do some work on it, drain out the pool. So these are inverse processes. If we delete a file, fortunately, this wasn't always the case, but we now have a process called undelete sometimes. Now, usually what it does is it puts it in the trash, and then as long as you haven't thrown out the trash, you can undelete it, right? So that's your inverse process. Bring it back, put it where it was. However, some processes do not have an inverse. They cannot be undone. So once you've emptied your trash, oftentimes it is not possible to bring things back. I said oftentimes, sometimes if you've got the technology, you can actually still recover things off of a disk. But anyway, those are processes we're used for. And again, we could also think of it going the other way. If we filled up a hole, then we could dig it later. So a lot of processes with inverses can go either way. But what about in mathematics? Especially when we're dealing with a function, what is the forward process we want to think of? Well, we have an input, and then we have some kind of a rule, some mathematical rule that does something. And that gives us an output value. So what would a inverse function look like in math? Well, it would start with the output, and it would do a reverse rule, unrule, let's put unrule, an undoing rule, and we get back to our input. And math is filled with these types of forward and inverse processes. So if you think of addition being a forward process, what would be the inverse process? Subtraction. If we think of multiplication as the forward process, the inverse process would be division. If we have a squared, or let's do with the square root, should do that in red, then the process is to square it, right? So we've got these kind of processes that bring us back and forth. So we're going to look at a few examples, but basically what this does is the function, the forward function, takes the input, moves it over to the output. The inverse function, what we're going to see, we're going to call the inverse. It's going to take that output, which we'll put x in here too, which is kind of the confusing part, but it takes the output and gives us to the input if we were to keep our letters the same. Unfortunately, we start writing, well, let's always have x be the input, even when it's a y value, let's call it an x value. They sort of do this swap. So that's something we get used to. But the forward function takes x, does something to it to make it into y. The inverse function that would go with it takes the y value, undoes everything that was done to it, so it gets back to where it started from. And we use this little f to the -1 notation. It is not an exponent, it is just a way of writing it. It's a symbol, okay? So let's look at taking a linear function. We'll just start with a linear function of f of x equals 2x minus 5. Could have chosen any example. Okay, so what we're going to do is, to make the notation a little easier, we're going to replace this f of x notation with the symbol y. That's the output. They really mean the same thing, but it just simplifies our lives in writing things. And here it is. Remember, it's sort of like the x. I put in an x, I do the math, and I get to the y. So to create an inverse, all you really need to do is switch the x and the y. This is the inverse step. And so we just rewrite this as x equals 2y minus 5. Then so that really is the inverse. It would accomplish it, I guess. But then what we want to do is we want to solve for y. And this is why we get to this notation again, because x now really is an output. Don't get too confused, but it's just take that step, switch the x and the y, and now mathematically we'll solve for y. And what you're going to see in an inverse function is whatever happened in the forward function up here, we think what's happening to x, well, x is multiplied by 2, and then we subtract 5. So the inverse should do all of this backwards. In fact, what it should do is it will take the input, or it will take the value, the inverse, what we're going to see. Instead of subtracting 5, it's going to add 5. It's going to do everything in the reverse order. And then after that, it will then divide it by 2. So notice and just think about it. If you took something apart, how do you put it back together? Well, you do everything backwards. Lefty, righty tighty, lefty loosey. So if you're putting in screws, you go the opposite direction. But you also got to do it in the opposite direction, right? Because you got to start from the outside in, and then when you put things together, you start from the inside out. Okay. So the forward the process goes this way. And then the inverse has to go the other way, and it does the opposite things. So we're going to see that happening as we solve for y. So first thing we do is we add 5 to both sides. So then we get x plus 5 equals 2y. Then we need to switch colors. I get divide by 2 and divide the whole thing by 2. So really what's happening is x plus 5 is getting done first. And so we end up with our inverse function being x plus 5, then the whole thing divided by 2. And what we do is going back to function notation. So notice how we brought a y in because we wanted to make it easier. Then what we do is we say, okay, this is the inverse, and if we just leave it y equals, it's hard to tell that that's an inverse. So we rewrite this as f inverse of x equals x plus 5 over 2. Now, the thing is, and again, we just we get used to it. This x really is a different x than this x. Okay, this is an x that has already gone through the process and become an output, and then when we put it back in here, it goes through. So it truly is x is just marking a spot for the input. Okay, but I don't know. We'll leave it at that. Okay. So let's look at another example. And as we look at this example, we're going to look at a square root example. The domain for the square root has already been determined for us. It goes from negative infinity to 5. And we can see if you plug in 5, 5 minus 5 is 0. And as you plug in numbers less than 5, so 5 minus a number less than 5 is positive. We're keeping this. And again, what they did is they just took 5 minus x, has to be positive, right? So it has to be greater than or equal to, sorry, has to be greater than or equal to 0. They solved this. Again, I did this earlier. Is just, let's just add x to both sides. So 5 is greater than or equal to x, or x is less than 5. Here's 5. 5 is included, and this part, everything less than that, all the way to negative infinity. So that's how they got the domain. And now they want us to find the inverse of this function. So we'll go ahead and do that. Now the inverse function will also have a restricted domain, but what we're going to see is, since remember the domain refers to the x value, range refers to the y value. So wouldn't it make sense that when we go to the inverse function, that whatever the domain is will become the range, and whatever the range was will become the domain. So hopefully it makes sense to you, because that's exactly what happens. So the domain of the inverse is going to be the range of the original function, and the range of the inverse is the domain. So the x and y is truly just switch places. Now while we're talking about that, before we get too much further, I'm kind of, there's some notes, remember, in Canvas. You can kind of walk you through each one. These videos are kind of designed to be more of a conversational talk through this. There is a line, y equals x. And what it looks like is, x and y are the same value. So when x is 1, y is 1. When x is 2, y is 2, so forth and so on. And along this line, notice if you switch the x and the y value, you can't tell the difference. Let's just choose one here. Let's call that 5, 5. Switch the 5s around, it's still 5, 5. So what we're going to see, another property of inverse functions, is they are reflections about this line y equals x. So it's kind of cool. We're going to graph a few of them, and you'll see whatever this graph looks like, the graph of its inverse is that graph reflected over, because literally all that is happening is each ordered pair x, y is getting switched, and we're graphing it in the order of basically y comma x, right? But the y is now the first. So everything switches. Okay, so with that said, let's first take our function and rewrite it as y equals the square root 5 minus x plus 7. And we'll just kind of keep this in mind, that we're dealing with this kind of a domain, but we won't worry too much about it. So this is the first step, is switch the x and y. So we do that, we get x equals square root of 5 minus y plus 7. Literally, we just switch the symbols. And now we need to solve for y. So again, you kind of see a order of operations. We've got the square root thing, can't quite get to the y yet, so we'll subtract 7 from both sides. That gives us x minus 7 equals the square root of 5 minus y. We've got to get that y out of the square root, and so what we do is we square both sides. So when you square a square root, that cancels out. So now we have 5 minus y, x minus 7 squared. We can subtract 5 from both sides. So then we get 5. Subtract 5. We get x minus 7 squared minus 5 is equal to negative y. Multiply both sides by negative 1. So that will turn that to positive y. It puts a negative here, and that makes that positive. So we'll move the 5 to the front. Positive 5 minus x minus 7 squared. Now we could FOIL out the x minus 7, or we could just leave it as is. I mean, it's okay. It's a function. It's as is. I'm going to choose to just go ahead and leave it that way. But we'll rewrite this. I'll bring the y over to the other side because we get used to that. The inverse function of x is this, is 5 minus x minus 7 squared. So notice plus 7 was the last thing that was done up here. Subtracting 7 is the first thing that gets done. Then it's going to get squared, and then it's going to get subtracted from 5. So that's the one thing that looks to be about the same. That's not really getting changed. We're still taking something, but we're squaring it before it happens. So let's go ahead. Let's see if I can do this. We're going to go to Desmos. We're going to graph these two, and let's see if we can see this property of this y equals x if this reflection happens. So we have 5 minus x plus 7. Let's come here. We'll just drop over to Desmos, and we'll put in f of x. The original function is what we're going to graph. We've got the square root 5 minus x, and then we come outside of the square root, and we're going to add 7. And if you've been through the part on the translations, which you hopefully should, we notice that plus 7 just moved it up. And so what we see here is here's 5. The domain is less than positive 5. We see that happening. Okay. And while we're at it, let's go ahead and put in the graph of y equals x. So we have that going for us. So now we could just sort of see this thing being reflected over. And let's put in our answer and see if that actually is what happens. So instead of use, the notation won't look good. It might not behave very well in Desmos if we use f inverse of x. I'm not quite sure what it's going to do. So we'll do this. So what did we end up with? We had 5 minus x minus 7 all squared. But here's the thing, we got a parabola, and that's not what we had over here. Remember, we had a restricted domain. So we do also have to restrict our domain because this green function that we have now is not a one-to-one function. It couldn't have an inverse. And so this is where we can take advantage. We can kind of see here that when x equals 5, we want 5 to be, we really want this, the piece of this function that goes this way, okay? And we're going to see how that ends up working. And I said x equals 5, but I was misled a little bit. X is actually equal to 7. We want the domain where 7, x is greater than 7, right? And we'll see how that does. So let's come back here. And remember, we use, where's our funky brackets? Let's see. I went here, that's right, put the bracket, and we want x, hopefully I can use that x, is greater than or equal to 7. There we go. And then I go back and get the other bracket to make it look nice. Okay. So again, I could put that point there. And what we start to see, let's see if I can do this, the endpoints. Notice this is 5, 7. This is 7, 5. Fortunately, at this point, it doesn't give me those endpoints, but we can see them switching places. We see the reflection looks like two wings. The red reflects right over to the green. We can see here the x-intercepts 9.2360. What do you think is going to be here? It's going to be 0, 9.236 for the y-intercept. So notice the x and y's are just switching places. So it really does all work when we get these inverses. But what we notice, okay, so the domain of the first function, we'll do that in red. Go with the red one. The domain was negative infinity all the way to 5 and including 5. So we know that down here in the green, that's going to be the range. The range is going to be negative infinity to 5. With the green, we found that we had to make this, so that it was 1 to 1, we had to take the domain and make it so that it was x is bigger than 7, go all the way to infinity. Okay. So we can also see here that this value here, the y value is 7, right? And there are no y values below 7, they're all above 7. So you might also see that the range for this one is going to be 7 to infinity. So you can figure out either one. Once you figure out the range of the forward function, that's going to give you the domain of the inverse function. And when you have the domain of the forward function, then you also have the range of the inverse function. So again, they switch places because the x and y's are switching places. Okay. So that all worked out fine. We've got one more example to take a look at. So we figured all that out. And let's go ahead and look at this last one. And this one is a little more complicated when we talk about finding domain or range, but we can be okay. It's also using this process of finding the inverse is algebraically a little bit more complicated. Okay, so we're going to go through this. It's the one-to-one function, g. So we're already told it's one-to-one. We don't really need to make it one-to-one. And that's one of the things is, if you look over the notes, for a function to have an inverse, we have to have it one-to-one. If it's not one-to-one, then you'll have two inputs going back to the same output, and it won't be a function. Okay, so let's take this one, and let's rewrite it as y equals 2x over 5x minus 4. And these are ones, once we're done, it's really hard to see the inverse. It's hard to tell what's happened, but you see the same numbers. You'll see the 2, the 5, the 4. They'll be in different places. So let's take our first step is to switch. X and y. And so we're going to rewrite this as x equals, notice we're going to end up with two y values, right? 2y over 5y minus 4. And this is where the difficulty comes in, is we're going to solve it and we're going to have just y equals. So we're going to have to do some factoring and some moving things around, but we'll be okay. So first thing is to get rid of the fraction. We'll multiply by the denominator. on both sides, 5y minus 4 and 5y minus 4. On this side, they cancel out very nicely. So then we're left with 5y minus 4x equals 2y. Now, how are we going to get these y's together? Well, let's just keep moving forward. Let's simplifying. It's, the y is inside of a parentheses here, so let's distribute this x. So we get 5xy minus 4x equals 2y. Since we want to solve for y, we want to get everything with a y on the same side. Again, we could, the simplest way with one move is to subtract 5xy, because then it moves it over here, 5xy. So this becomes 0. We get negative 4x equals 2y minus 5xy. And now this is not as obvious until you've done it a few times, but what we're going to want to do is we want to factor out a y, and then we'll have a piece that we can just sort of divide by. So let's, if you factor out a y, you're left with 2 minus 5x. That way. And that's equal to negative 4x. What you can see is now to solve for y, we simply divide by 2 minus 5x. And that's going to give us our inverse function right here. Now, there's some formatting issues. You can write this just as it is. You could change the top to a positive by moving the negative downstairs, and so this would become, the 2 would become negative, the negative 5 would become positive. So I'm just going to talk us through. I'm going to write this in 2 different formats, that the inverse function of g can be written just as it is, negative 4x over 2 minus 5x. But sometimes you get these multiple choice tests, and for some reason they say, oh, we want to make it look pretty. And so they change it, they put the negative, they move the negative to the denominator. So then they say 4x, the 2 became negative, so we're going to do that, and the 5x became positive. So it looks like that. These are equivalent. And like I said, you still got the 2, the 5, the 4, but they're kind of all in different locations, and it's beyond me to kind of figure out what inverse stuff is going on, but it all worked, okay? And so what we can do is we've got the inverse function. Haven't worried about the domain as of yet, but they do want us to state the domain and range of the inverse function. So let's go ahead and do that, and then we'll do a graph and we'll see that it all looks pretty nice. Okay, so first of all, the domain of the forward, what I'll call the forward function. Remember, the only thing for domain, we can't let the denominator be 0. So we're going to take the denominator, and let's just go up here, some scratch work. We set it equal to 0, and this is what we're going to have to exclude. So then we can add 4 to both sides, giving us 5x equals 4. And then we divide both sides by 5. And so then we get x equals 4/5. Now remember, that's what needs to get excluded. So the domain up here is going to be negative infinity to 4/5 union 4/5 to positive infinity. So we take out that one value. Now that I've got the inverse function, what's going to be, at least in my mind, what's easiest is to find the domain of this function, and that will give me the range of the forward function and vice versa. Okay, so the domain, I've got to take the denominator, doesn't matter what's in the numerator, we set the denominator equal to 0. We're going to add 2 to both sides. So that leaves us with 5x equals 2. Divide both sides by 5. And so we see we need to exclude 2/5. And so down here, let's do it with green, the domain of the inverse function is going to be negative infinity to 2/5 union 2/5 to positive infinity. Then the range would be all the y values, and all I got to do is say what it's also going to be the domain of the forward function, so I just copy that down. So that's negative infinity to 4/5 union 4/5 to infinity. So that's how I just said, okay, this thing has to be the range. So there we go. So really I find the domain of both the original function and the inverse function, and then I do a little flip thing around. If I want to, up here, I could say now I know the range of this thing, not directly, but in the graph we might be able to see it. Sometimes range is harder to see, and that's why we can solve for the domain, and when we have these inverse functions, it's kind of a nice, kind of run out of room here, 2/5, right? 2/5 to infinity. So let's finalize this by going ahead and graphing both of these functions and seeing what it looks like as a reflection over the line y equals x. So we've got 2x, 5x minus 4. And again, maybe, well, you can always take screenshots of these videos. As soon as I go to decimals, I lose everything I wrote. So make sure you've got all of that. Well, I didn't want to go there yet. We're not quite done. Well, maybe if I do this, if I go there and then I go to, let's see, no, it's going to make me keep them or discard them. Let me just see what happens if I keep them for one time. Go over to Desmos. I would like to clear this out. And let's clear these guys out. So we're going to graph, and maybe we're not too concerned about function notation so much. So just y equals 2x divided by, what was that, 5? That was 2x or 5x minus 4. So that's what that's looking like. And we'll be talking about these in a little bit, rational functions and these things called asymptotes and everything, but it looks like there is, actually let me use this one. There's kind of like right along here, there's a hole, and that would be one of them. And then there's one here. One will be 4/5, the other will be 2/5. I think this is the 4/5 one, and this is the maybe the other way around. Anyway, so that's that. What we will do is then we will next graph y equals x. And there's our reflecting line. And then let's graph that last function we came up with, which was y equals, what was that, 4x? What did we come up with? 4x over 5x minus 2, yes. So then I got 4x Oh, I see. So we get y equals 4x over 2 minus 5x. I think that's what it was, wasn't it? 5x minus 2. So actually I could fix it by putting the negative up here, right? And we kind of see what's happening, on the line y equals x, they're both going through that. And then if you were to flip the purple graph over that line, see if I can sort of draw this part would match up with that part, and this part would match up with that as we flip it over. And the same thing that happened is the part of the purple, since it's the forward function, gets switched over here, and this one gets switched over there. And the best way to spot that, if you can, is to kind of look at some points, x and y. So here when x is 1, y is 2. So on the blue one, when y is 2, x will be 1. So from the purple, we get 1, 2. Onto the blue, we get 2, 1. So x's and y's are switching places. Kind of a mess. We look at it that, but that's what's going to happen with inverse functions. Okay, and so take a look at the notes. That should help as well. But just remember, it's really to find an inverse function, just switch the x and the y, and that's what an inverse function is. So this is the end of the direct instruction part. Go ahead and work through the few learning activities for Module 6. And remember, there's help with our online tutoring. We've got our instructor office hours, and as well as our discussion forums where you can collaborate with your peers.